The broadcast is now starting. All attendees are in listen-only mode.
Welcome everyone to our webinar today, Eliminating Wastewater Odors with Permanganate Oxidation Chemistries. I'm Liz Mueller, our Marketing Manager here at Carus Corporation, and today we have Mr. John Boll who will give our presentation. Just a few housekeeping items before we get started. We do have everyone in listen-only mode. This will help cut down the background noise. If you have questions as you think of them, feel free to enter them into the questions pane. You can see a screenshot of it on the right-hand side here. We will have time at the end for question and answers. If for some reason we don't get to all the questions and answers, we're able to see your contact information and the question that you asked, and we'll follow up with you directly after. We are also recording today's webinar, so if you would like a copy of the PDF of the presentation or the recording, please contact me. And a few ways to find us: visit us at our Carus Corporation website, which is www.caruscorporation.com, or follow us on our social media platforms where we'll frequently post any upcoming trade shows, trainings, webinars, recordings of the webinars, product highlights, employee highlights. We're active on our YouTube channel, Facebook, Twitter, and LinkedIn. And at this time, I would like to introduce our speaker, which is Mr. John Boll. John is our Global Technical Program Manager at Carus Corporation. He has been with Carus for over 40 years, serving in a variety of sales and marketing positions. The Technical Service Department provides customer support, including on-site lab testing, plant scale startup, and troubleshooting services. John earned his BA in Engineering from Purdue University, West Lafayette, Indiana. He is a member of the Water Environment Federation, WEF, and the American Water Works Association, AWWA, where he served as the AWWA Illinois Section Chair from 1992 to 1993.
All right, thanks Liz for organizing today's webinar, and welcome to all of those who are attending today. I hope that all of you are at least somewhat familiar with Carus Corporation, but if you're not, let me start with a brief introduction. Carus provides and supports chemistries that are used in environmental cleanup and pollution control, and for improving the aesthetic qualities of water and air. And Carus has a strong background in permanganate chemistry, in particular, permanganate manufacturing, permanganate chemistry expertise, and in technical support. In today's topic, we're going to explore permanganate and the fact that permanganate purification of water and air and solids and oxidation chemistry in general have been shown to be very effective techniques for eliminating nuisance odors. There's a long history and a lot of literature published on permanganate chemistry for this particular use, and it's been shown to be effective over a broad range of odorous chemicals, and it's used by a variety of different industries and at many unique sites where odors are released. And in particular, oxidation reactions with permanganate generally are very, very fast. So interestingly, over the past several months, we've had a number of requests for information on odor control. And I say this is a little bit unusual because we've had rather extended winter here in the northern part of the United States. And odors are really more of a hot weather, summer type of issue. But it did lead us to the idea that maybe the time was right for a webinar presentation on permanganate's role as an odor control technology, and to review in particular the various forms of permanganate products that we offer and how they make permanganate effective and easy to use. Now in this presentation, I'm going to build a very brief foundation by introducing some basic concepts on odors and a couple that will simply review oxidation chemistry and specifically permanganate's unique oxidation chemistry. And that will lead us to the real purpose of this discussion, which is to describe the many permanganate products that are now available. And finally, how to identify different odor release and treatment scenarios that show how we can match the specific product to that particular location. So the problem of odors, it's a difficult one. Odors and developing effective odor control is tough to solve, and in particular, one aspect of monitoring and tracking odors is that we have to rely on our nose, the human nose, as our detector. And that can make effectiveness a difficult goal and one that can be quite subjective. You can see here on this particular slide, I've used an EPA diagram which shows that response to odor compounds by the human nose follows a sort of normal distribution. So there are some people at one end of the spectrum who don't recognize very many odors at all. And then we have the very highly sensitive population up at the right-hand end of the curve. And that makes odor measurement and detection a statistical analysis in particular. Now, our sensory perception of odors really has four major components, and they are the concentration of the compound or the element, the molecule, its intensity and how we respond to it, its characteristic, and the hedonic tone of it, which is whether it's rather pleasant or rather unpleasant. Now, the concentration is measured usually using a panel of people who are smelling different samples that are diluted with odor-free air. And there's a statistical analysis that tells us the detection threshold or the recognition threshold, and that's usually 50% of the panel that indicate that they have detected or recognized a particular odor. In particular, though, I want to focus on the odor characteristics. So it's very common for us to identify odors based on how we respond to or how we recognize what that odor reminds us of. So, for example, we can describe an odor as being fishy or nutty or rancid or sewer-like. And these are important because they are tied to the molecules that we're detecting. So odors are volatile chemicals that are released into the air where they can be detected by our nose. And our perception of odor is triggered by the shape and also the chemical functionality on a particular molecule. Now notice that these molecules that are shown here have very distinctive shapes and elemental structures. And remember that on paper or on screen, these molecules look flat, but in actuality, they're three-dimensional. And I also want you to notice in this particular slide the different functional groups on these molecules. So we have a phenol structure or an aromatic structure. We have alcohol groups on these molecules. And we have unsaturated double bonds that contribute to the structure of these molecules. They're important when we investigate how permanganate may or may not help to solve an odor situation. So what is permanganate? Permanganate falls naturally into really two chemical buckets. The first is the group of manganese, the fact that it's a manganese compound. And manganese is a transition metal that is, like iron, found throughout the environment and is present in soil, water, plants, and animals that we live with every day. Now, when we manufacture the permanganate, it becomes and falls into the category of oxidizing agents. And that is the chemistry that we take advantage of when we're doing environmental work. So during the manufacturing process, we inject energy and add oxygen into the manganese backbone that we start with. And to the chemist, oxidation reduction chemistry often involves the transferring of electrons. But if you or someone you're working with is not really familiar with chemistry or with oxidants in general, it's easy to think of an oxidant just simply as energized oxygen. Now, it's likely that the name oxidation is a result of observations of our physical world. We live in, after all, an atmosphere of oxygen. So it's probably soon noted that almost all elements form oxide compounds just through exposure to air. Now, there can be very violent oxidation reactions, so that when heat and light are involved, this rapid oxidation is often referred to as combustion. Note the reactions shown here, the burning of a match and the rusting of metal, just due to the oxygen that's in the air. Now, oxidation chemistry is actually important and actually is quite fun because it's a very versatile oxidation chemistry. Oxidants can be used and are often used to synthesize other materials. So we start with simple molecules and we convert them into something a bit more complex so that they can be used in a variety of different functions. However, in the environmental applications that we're generally talking about today, oxidants are very effective at breaking down large molecules and converting them into smaller bits, which are odor-free or tasteless, or are not any type of environmental problem after they're made that way. So here's permanganate's half of the oxidation chemistry, or half of the oxidation reaction. On the left, you see the MnO4 ion. That's the permanganate ion that we represent here in purple color, because when permanganate is dissolved in water, it has a very distinctive pink or purple coloration to it. Now, when permanganate reacts with a pollutant, it's going to contribute 3 oxygens to that reaction. These won't be free oxygen or dissolved oxygen in solution. They'll combine immediately with the compound that we're reacting with. And the manganese portion of the reaction will precipitate out as a hydrous flock of manganese dioxide, which is MnO2. The functional groups that permanganate tends to be very, very effective at reacting with are shown here on this particular slide. Permanganate likes to react with unsaturated double and triple bonds on organic molecules. It is very good at reacting with alcohol groups and the reduced sulfur equivalent of that, which would be a mercaptan type of compound. Permanganate reacts with phenols, with aldehydes and ketones, and it also reacts with nitrogen-containing compounds such as amines. In our research work, we look at very specific compounds that are odor producers. Here you can see a variety of different mercaptans, and we include hydrogen sulfide on this slide of reduced sulfur odor compounds. Of particular interest on this slide is that you can see the different compounds have different characteristics that are associated with them and are very distinctive to when we recognize them in the environment. The other thing to note here is that these odors can be detected by the human nose at very, very low part per million thresholds, which is one of the reasons why controlling odors can be very, very difficult. Beyond the sulfur compounds, there are a variety of different nitrogen compounds that we react with. Different kinds of amine compounds are particular in this group, and those are the very fish-like or ammonia-like odors. You get into more distinctive compounds such as cadaverine, which is considered to be very rancid type of odor. And on this slide, we also show one of the aspects of odor molecules is that they can take on different characteristics depending on how concentrated or dilute they are. So indole, for instance, at very low concentrations can be considered to be flowery, where at very, very high concentrations it can be considered to be a very fecal type of characteristic. There are other specific organic compounds that we can react with, from phenols and creosotes, styrenes and aldehydes of different types, benzaldehyde and acetaldehyde, butanol, which is an alcohol, and then just general odor emissions from different types of industrial processes, such as rendering plant off-gas and asphalt plant off-gas were researched quite heavily, and permanganate was quite effective at controlling those particular odors. Where are the points of odor release, and what are we looking for when we go to a particular site? It can really be released at any particular type of process or treatment step, but it's most often when the temperature of the water is high, because the gases are less soluble in water at high temperature. Whenever there's a high surface area, such as a large clarifier or a pond or a lagoon, you can have a high flux rate because of the surface area. And of course, anytime there's pumping, mixing, spinning, squeezing, or cascading type of turbulence created, then these volatile odor compounds can be released. So how do we look at these things from a practical standpoint? We know that the chemistry remains the same. The permanganate chemistry from site to industry will always be that permanganate will be reacting with an odor compound to produce an odor-free emission. The permanganate reacts rapidly and completely so that it's often added very close to where the odors are being released. So how do we apply this solution at the site of the problem? And one way is to engineer the product to be easy to use regardless of where the odor release point is. So let's look at some of these permanganate products. And I'm going to start with potassium permanganate, which is really the workhorse product. It's the product that is manufactured at all manufacturing sites as the first chemical. And it can be produced in different grades. So we can produce just technical grade material, which is 98% pure. And in a lot of cases, we blend it with a desiccant to make what we call the free-flowing grade. And free-flowing is probably the single most popular grade of potassium permanganate that's manufactured. Permanganate is a stable product, so and it's stable for quite a long period of time. So we can manufacture it and package it and deliver it to the customer site in a sealed container. Potassium permanganate has a kind of a broad spectrum of particle sizes, some of which are quite fine, and the permanganate product as a dry product can be rather dusty, especially when there's the free flow desiccant that's added into the product. And this dry crystalline material is often fed and metered correctly into a treatment process through a dry chemical feeder, where there's a hopper and a screw type conveyor which meters out the correct amount of material. But the dry product is never added directly into a treatment process. I shouldn't say never, but not often fed into the process as a dry material. It's almost always first dissolved into water and then taken to the point of application as a water solution. Now there's a special form of potassium permanganate that we like to use, and that's what we refer to as nuggets grade. It's a product that we can make in our process. It is much larger in size than the technical or free-flowing grade permanganate products. And we can use the fact that we have these large chunky types of crystals present to use them in a variety of different application areas that we'll talk about in a little later. We also are now manufacturing a product that We offered a number of years ago and then stopped manufacturing, but are pleased to say that we're back and producing again in a slightly different format. And that's the Carus CR tablets, which are a permanganate product where we add a binding agent and then press the material under pressure to produce a hockey puck type of product that in flowing water, or when immersed in flowing water, releases the permanganate slowly and in a controlled way. And these are products, these tablets are primarily permanganate in nature. They're 70 to 80% permanganate assay. Now, in addition to the dry crystalline products that we manufacture, permanganate is also manufactured as a concentrated liquid. And there are really two grades of that available. One is Carusol liquid, which is 20% active ingredient. And the second product is Carusol C, which is a more concentrated form and is offered as a 40% active ingredient material. These products are also very stable and can be packaged and delivered to the site in sealed containers. We manufacture different types of permanganate blended products as well. An example of that will be Totalox odor eliminator product, which is a special blend of calcium nitrate, 40%, and permanganate, 1%. And this product is specifically manufactured for wastewater collection systems where you're trying to control odors for a long distance or a long time period. I mentioned earlier that permanganate oxidation chemistry is one that is very rapid and reacts quickly with the odor compound. But in a long transmission line, you may want to control odors for long distances and for long time periods. And that's where the nitrate product is particularly effective. So the combination of the two provides very quick oxidation reaction where the product is being introduced to remove odors at that point, and then the nitrate product controls the formation of odors further on down the pipeline. I've included in this presentation a product that is not manufactured by Carus Corporation, but is manufactured by a company called Purifil Inc. And that's a Purifil product where permanganate is coated on alumina spheres and is used as a dry filtration type of media for controlling contaminants in air. It's particularly good when the contaminant load is low and when it reacts rapidly with the permanganate coating on the outside of the pellet. So it's used often for reduced sulfur compounds such as hydrogen sulfide and sulfur dioxide. It's used for indoor air quality improvements, so it removes formaldehyde from the air. It also reacts with nitrous oxide, NO. And it is used often in controlling off odors in large rooms such as auditoriums or airline terminals, and for protecting in particular electronic devices which would be particularly sensitive to corrosion due to hydrogen sulfide. So let's switch over and let's talk about different types of application sites that we run into and how we can fit permanganate products to meet those requirements. So here's a very common site where we're working at a treatment plant of some type or an industrial plant. The aspects of this which are important to us are that it's a secured facility. There'll be a locked fence line around it so chemicals can be protected. There's access by road to vehicles, so you can deliver chemicals to this site, and it has probably unloading capabilities as well. We, of course, have electrical supply and water supply at these particular sites, and we have access to weatherproof structures. So what products might we use if we're trying to control an odor problem at a treatment plant site? And that really includes all of the products that I really introduced. We can use the potassium permanganate dry products, feed them through a chemical feed system, or manufacture or prepare a concentrated solution of those products, put them in a storage tank, and then meter that concentrated solution using metering pumps of some type. Or we can simply deliver the concentrated products that we manufacture here and then deliver to the site as a packaged material in, say, totes, or as a bulk product that we can deliver directly into a storage tank where we would then meter the correct amount using metering pumps. Within the treatment process itself, we sometimes treat biosolids or odorous solids of some type that are being dewatered. Again, we have almost all of the necessary requirements of secure buildings and vehicle access and utilities, electrical and water utilities present. So we can use almost all of the products, again, that we can offer, from the dry crystalline permanganate products to the concentrated liquids. The concentrated liquids are used often because they can be installed easily. A small metering pump can be introduced very, very quickly, and we can get up and running in a very short period of time, injecting the permanganate directly into the wastewater sludge solids on their way to the dewatering device. We even use these products to treat drying beds, where we can treat the surface of the material and destroy any odor compounds that might be released from that exposed surface area. We often are working at collection stations and pump stations in municipalities where waste is being collected. Sometimes it is an easy site to deal with. We have a building in place, and in this particular case, we actually had a building where chemical storage and feeding areas were already designed into the process. You can usually deliver material to these sites very, very easily, and you have water and electrical supplies that you can take advantage of and use the different types of chemical feed equipment that are available. In this particular case, we were able to bring in drum sizes of the Carus liquid product, and we mounted peristaltic feed equipment for delivering the correct amount of permanganate on an hourly basis. In this particular case, I mentioned that there was a chemical feed room that was already installed at this site, so that we had a chemical feed line that went out of the building and upstream of the wet well at this site by about 100 yards, where there was a chemical feed line that went into a manhole that was available in the upstream line. But collection system lift stations aren't always as user-friendly as the site that we just looked at. So here's a site where we do have an in-ground collection system, a wet well, and a pump station. It is secured with a locked fence, so it would be possible to site chemical feed equipment in this particular area. Access to it by vehicle is not particularly easy, but it can be done. We have electrical supply at this site, but we don't have any water utility other than the collected wastewater itself. And of course, we don't have a weatherproof structure at this site. Now, this might be a perfect site for using the controlled release tablets, particularly if the release of odors is not particularly high. You can also bring a tote into this particular site and use a metering pump to deliver the product into the collection wet well. The pumps are not particularly waterproof, so that they should be protected from weather and from rain in particular. And you can also site a small protective building on this particular location that you can place chemical feed equipment and the drums inside. Now here's a really tough situation, and that is, what do you do when the odor release point is from a manhole that's, say, in a sidewalk or in the middle of a street in an urban area? You don't really have any of the characteristics that we would be normally looking for. It's certainly not secured, so you can't site a chemical feed system near this particular site. And you don't have any electrical or water utilities available to you. So this is where the controlled release tablets are particularly effective. The tablets are usually placed in some type of porous container. There's a polyethylene mesh bag that we use and is available for holding the pellets. And then the pellets the tablets are dropped into or suspended into the flow that's going through that particular manhole. And the flow dissolves the material very, very slowly and in a controlled way. If you have a larger station, as in the picture at the top right-hand side, you might have to actually drop in a couple of different bags in order to get good distribution across a large flow area. But in a lift station such as this, the action of the increase and decrease of the level of the water in this station creates enough turbulence so that we can dissolve the material away. You can control the amount of permanganate that's being dosed in these sites by the number of tablets that you immerse into the water flow itself. Here's another particularly difficult situation. That's when you're working with lagoons that are releasing different types of odors. They may be secured. They may be on the property that is owned by the facility that is using this lagoon. So you can get chemical feed out to these particular sites. Deliveries are not particularly easy and must be thought through carefully when you're trying to deliver permanganate to these particular areas. And often you won't have any particular utilities, in particular any kind of water utility out to these sites. And of course they're open air and they're windy conditions, so using something like the crystalline potassium permanganate product is not easy because the wind will blow it around. So this is where we can use the products such as the liquid products or the nugget material, which is designed particularly for open air use. It's much less dusty than the potassium permanganate crystalline products. And it's designed to be broadcast into lagoons where it can treat not only on the surface, but it is heavy enough to fall through the total water column and down into the bottom of these lagoons where a lot of the odor is being generated. If the lagoon is small, it's relatively easy to use a fertilizer type dispenser to broadcast the nuggets from along the edge of the pond, or to use chemical feed that goes out to, as you can see here, different types of aeration that are already mounted into the lagoon, and where we can use the aerators as our mixer when we're feeding permanganate liquids out to those particular sites. In addition, I might just add that permanganate chemistry is particularly effective when we also have a lot of dissolved oxygen present, because that manganese dioxide that precipitates from the permanganate reaction works quite well as an oxygen transfer catalyst for a variety of different odor compounds. And I would mention that some of the types of application areas that we get involved in include concentrated animal feedlot operations. So the cattle industry and the hog confinement industry do use permanganate to control manure odors at these particular sites. In these sites, and also as in the case of drying beds for wastewater plant biosolids, we often make up a permanganate solution that can be sprayed onto the surface of these areas to control the odors that are being emitted. So that's a good spot to stop and see if there might be any questions that you have about either the products or the application areas.
Great. So one question that's come in is Purifil SP available through Carus?
So no, we don't resell those particular products. The best way to do that is to contact Purifil directly, and they will direct you to their local representatives who can handle that particular product for you. And they'll also work with you on the design of the container, the equipment that goes with that media, so that you can put a complete system together.
Great. And another question is in regards to feed equipment. Does Carus supply feed equipment, or can you just make recommendations of vendors and materials?
Yes, for the permanganate products that we manufacture, both the dry crystalline material and the liquid products, we can provide feed equipment and feed equipment designs through feed equipment companies that we work with. We often inventory pumps, metering pumps here at our site so that we can respond quickly to a request. But there's nothing that we do other than make sure that the products, these equipment products, are compatible with permanganates from a materials of construction standpoint. They are basically products that we can get and you can get from manufacturers directly as well. Good. So let me close then by saying a few things about chemical safety, which is always an important consideration when you're working with different types of products. So Carus takes safety very, very seriously, and we provide safety information through a number of different communication techniques. So certainly the Bible for safety is almost always the safety data sheets that are available for all of these particular products, and they contain all of the information that you would need in setting up and using these products in your particular facility or site. But also pay attention to the product labeling, where there's an awful lot of information, or specific literature pieces that we may put together that address safety issues. We can do in-house employee safety training programs for customers, and we have, for people who visit our facility or work in our facility, a safety training video that they all go through in order to be certified to enter the property. And of course we do a variety of different seminars and webinars regarding permanganate safety as well. As I mentioned, each of the different products has a safety data sheet that is currently up to date and meets GHS requirements. And on that safety data sheet, you will see that permanganate is a strong oxidant and that it can react as a dry material or as a concentrated liquid violently with oxidizable materials. But under normal conditions, it's a very stable product. It is compatible with a number of different other chemicals. And as a dilute solution, it's very stable, and almost all of the hazards go away when you have diluted it down. So remember that a safety data sheet is referencing the concentrated product as it's delivered to the site. So in the case of potassium permanganate, we're talking about the 98% crystalline material, and in the case of Carusol, the 40% or 20% concentrated liquids. And then just to close, I would summarize by saying that permanganate is a proven technology with over 50 years of research and field experience. It's available in a variety of different physical forms to make it easy to use and to match the types of situations that you might run into in the field. The odor chemistry is the same regardless of the product's form. It's the permanganate chemistry. And we can fit the product to meet the site location, make it easy to deliver, feed, and resupply that particular site.
Great. So just as a reminder to everyone that this is being recorded today, so if you would like a copy of the recording or a PDF of the presentation, here's my contact information. Please get into contact with me and we will get you that information. And just a few couple last minute comments. So as John mentioned, we have some safety literature available. So if you're interested in finding any of our SDSs, materials compatibility, we have neutralization documents, presentations, as he mentioned, please let us know. That information is on our website as well, but we'd be happy to share that with you. As well as hot off the presses, we have an odor control brochure that we are just finishing up both for US and Europe. So it will go through all of these products that John mentioned today. And the Total Ox product that John mentioned, we have just in the last 2 weeks been awarded an award from the American Chemistry Council, so ACC, for that Total Ox product as a sustainability award for its manufacturing process. So we're very proud to have just received that in the last 2 weeks. So this webinar has been very timely on a few of our efforts that we have going on here at Carus. So with that, we thank everyone for joining us. If you think of any additional questions once we end here, just get in touch with us and we'd be happy to follow up with you. Thank you.